In this last video for this unit, I'm going to touch on security through network design. So I'm going to talk about 4 network design principles that we use in network security. The first one being the use of a demilitarized zone. The second, subnetting. Third, virtual LANs. And remote access. So we'll talk about these 3. Let's start with the demilitarized zone, or the DMZ. I'm sure most of you have heard the term. Many of you are familiar with it and have probably used it in your co-ops or your jobs and so forth. So the demilitarized zone is basically a separate network that's outside of your internal secure perimeter. And this is where we put any services that have to be accessed from outside of our network. So the untrusted outside users can access our DMZ, or our demilitarized zone, but they cannot access the secure network without us having some special rules that allow them to do that, or using a VPN, for example. So the most secure approach to this method is to have 2 firewalls. Although I think with most modern firewalls, it's very easy to set this up with a single firewall device. You just have 2 different interfaces. Although the argument goes that if it's a single device, it's more possible for an attacker, for that traffic to leak through from one interface to the other. So the textbook answer is, of course, they have 2 different firewalls. One that protects your DMZ from the internet, and then a different firewall that protects the secure internal network from the internet, and they're different environments, more or less. Although users in the internal network can typically connect to the DMZ to access resources without having to go out to the internet and come back in and loop back in. So again, a DMZ is definitely the state of the art. People have been using DMZs for a long time. Almost every network that has any service that has to be publicly accessible from outside the network is going to have a DMZ. So you'll find they're pretty common. And here's a photograph here of using 2 firewalls instead of just 1. So if you have just 1 firewall, typically you'll have 2 interfaces, one for the DMZ, one for the internal network, and then of course a third one for your WAN zone. I did talk about this in some detail in the previous course, the follow-on from this course in CT395. Another concept, which again we talked about this in the previous course, is subnetting. And I'm sure you've done subnetting in other classes, but basically a subnet is when we can take a single network and divide it into parts, or sort of a network of networks. So rather than having one large network with everyone's traffic on one network, we can break that network into smaller parts so that they can be segregated from one another. And the concept that allows us to work is classless addressing, or CEDR addressing, classless interdomain routing. And that's what really allows us to do subnetting. And you've probably played with CEDR addressing in other courses where you do subnet masking and things like that. So again, this is another technology that we have available to us. We can divide our network into different parts. So we can have one network, say, for example, for the research and development department, another one for accounting, another one for HR. And that traffic does not, if we're communicating within the same subnet, the traffic never has to leave that subnet. That's the basic idea. So even if somebody were able to access, say, a mirrored port in a switch, it's on a different network, so it doesn't matter. That's kind of the idea. And again, this comes back to the layering concept, that we're trying to layer these different technologies so that we have various protections against these things happening. So there's just a picture of different subnets from your textbook. So each network can contain several subnets. Each subnet is connected through different routers and can contain multiple hosts. I should correct here that in some cases you can use, instead of routers, you can use switches. They do have switches that are aware of subnetting and can pass that traffic. But I guess the textbook answer would be that you route that traffic, which is true. Even though it's a switch, it's still routing that traffic. It's still working as a router. So a single network can be broken into smaller subnets to isolate groups of hosts, which I just spoke about. It allows network administrators to hide internal network layout from the users and from our attackers. The other, and I just touched on this a second ago, but virtual LANs, or VLANs, is another option that we have. It's where we can segment our network by separating devices into logical groups. So a VLAN, you can scatter VLANs throughout the organization, so you can have different switches with the same VLANs and things like that, depending on how sophisticated those devices are. But basically, it's the same idea of subnetting. It's the same concept. We're trying to isolate portions of the network from other portions of the network. And this is just a different technique to do that. Most modern switches do support VLANs. VLANs, when I think about VLANs, usually I break it into 2 categories. There's VLANs that are based around the idea that you have that you can isolate different networks on a switch. So you can create these sort of virtual LANs within the same switch. So if you jack into a certain port, you're only going to connect to that particular LAN. If you were using subnetting alone and you have two different subnets connected to the same switch, theoretically those devices could still talk to each other. They could still communicate with one another. But with some switches, you can isolate that using VLANs. The other concept with VLANs is VLANs can span geographic locations with some devices and some network topologies and technologies, I should say. And in that case, then the LAN technology is transparent to you as a system administrator. You can have one LAN that spans a large area, and there's different technologies that support that, such as MPLS and so forth. So that's the other option. All right, so the last thing we'll talk about here is remote workers, which are obviously important. Remote workers are becoming more and more common. Many companies are using telecommuters now. You have traveling sales representative, workers that just have to travel every day. Lots of jobs now, you have, well, it always has been that you have to travel for meetings and things like that. And workers expect to be able to do things when they're on the road. Unlike the old days when you went on the road and you were traveling, you pretty much had to phone it in. But now you could be sitting in a hotel and people expect to be able to do all their normal work as if they're sitting in their office. And one thing that supports that is going to be these technologies we have for allowing remote workers to connect to our network. And one of the challenges with this is a lot of, almost all of that information is it's traveling through networks that are not managed by us, right? It could be a hotel, it could be a conference center, it could be another company. I've worked, in many cases, I've worked for weeks at other companies where I'm working in another company's office because I have meetings with them that week, but I'm still doing my regular work. I jack into their network and I'm working from their network. So some of the technologies that support that is going to be, the primary technology that supports that's going to be VPNs. As I said before, we've talked about VPNs a few times in this class, and we've talked about the technologies that support VPNs, but we haven't talked about exactly how VPNs work, and I don't plan on doing that in this class. If you take a class such as Network Security 1 or 2, you'll learn how to actually create VPNs and how they work and understand those technologies. But what I can tell you is that we learned about encryption and cryptography and all of those protocols and vernacular that we discussed in this class and the previous class. You will see that when you set up a VPN. So when you go into the dialog to set up a VPN on pretty much any VPN device, you're going to see those same terms that we talked about, and understanding what they are and how they relate to each other and how they're being used, of course, is very important. But as I said, you can take other classes that will explain exactly how VPNs work, how to configure them, and get into much more detail in the protocols and things like that. But in any event, it's important to understand in this class that VPNs are the technology that we have to support remote access, whether it's site-to-site VPNs or software-based VPNs, which we've talked about previously. So that's it for this unit. If you have any questions, let me know.